Good morning, everyone. Welcome to Lecture 3. Today we will be discussing slope calculations. Please do not hesitate to pause and review any part of the video and feel free to let us know if you have any questions. To calculate slope, we simplify a surface into a line between two spots, and there's only one key formula to remember, which is raise over run. Raise divided by run. Raise refers to the vertical difference between the two spots, shorted for V. It can be calculated by subtracting their spot elevations. Run refers to the horizontal distance between the two spots, shorted for H. Here please note that it's not the same as the actual distance measured on the ground, shown in blue. Instead, it is the projection on the horizontal plane, so it can be measured on the plan. To be consistent with your exercise 3, we will use V over H instead of raise over run for the rest of this lecture. Just so you know, these two formulas are the same, they can be used interchangeably. To apply this formula, make sure V and H or raise and run are in the same units. There are three different ways to represent the slopes: percentage, gradient, and angle. In this class, we do not use angle in degrees to calculate or to represent slopes because it's more complicated in calculation and it does not help contractors in effectively understanding, building, or measuring slopes. So now let's look at the other two. Suppose we have a uniform slope. For every 300 feet of horizontal distance, the vertical distance changes by 3 feet. By plugging the values to the formula V over H or raise over run, we would come to a decimal value 0.01. So now we can decide which way to represent this slope. If we go for slope percentage, what we need to do is to multiply it by 100 and to turn it into a percentage. 0.01 times 100 equals 1. So now we can say it is a 1% slope. If we go for slope gradient, we need to convert the decimal value into a ratio. 0.01 is 1 in 100, so we can call it a 1 in 100 slope. Similarly, as you can see in this table, all slopes can be converted to different formats. However, please be mindful that do not confuse with these values. For instance, a 1% slope is not the same as a 1 in 1 slope nor a 1 degree slope. Now let's get back to our formula and more calculations. We could see that there are basically three different variables in this formula: V, H, and S. In any calculations, you need at least two variables to find the third missing value. This formula can not only help us to determine slope in percentage, decimal, ratio, it can also help us to find out spot elevations because they're relevant to V, vertical distance, as well as the locations of contours that are both relevant to V and H. Below, we will use some case problems to further illustrate. In this first problem, you have both spot elevations, 0 feet and 5 feet, and you're also given the horizontal distance, 125 feet, and now we want to find out the slope percentage. To do so, we need to first figure out V. So we subtract the two spot elevations. 5 minus 0 equals to 5. And then we just plug the values into the formula V over H. 5 divided by 125 equals to 0.04. And then we multiply by 100 to turn it into a percentage. 4% is our answer. Pretty straightforward. Now let's look at another problem. In this case, you have one of the spot elevation, 4 feet at the bottom. You know the horizontal distance is 50 And you're also given the slope in percentage, 2%. And this time, you need to find out the other spot elevation. To do so, to use a formula, we would know because spot elevations are only relevant to vertical changes, we would solve for V using the formula. So here, we need to transform our formula for a little bit. This portion involves some middle school or primary school math. What we did was simply to multiply h on both sides of the equation to cancel out the terms so that we will get v equals to s multiplied by h. Please let us know if you find any portion of this part doesn't make sense to you. We would love to help. And now we know the second format of our formula. V equals slopes times horizontal distance. We plug in the values 2% times 50, then we will get 1. 1 feet is the vertical distance. And the next step will be pretty straightforward. To find the upper spot elevation, we add up the bottom spot elevation and the vertical distance. 4 plus 1 equals 5. So now we know the other spot elevation is 5. So our last problem, we have a spot elevation, 1.5 feet. We also know the slope is 5%. And this time we want to find out where to put the next uphill whole number contour. So this question actually wants to find out h. And remember, we also said contours are relevant to both v and h. So it also tells us information about the other spot elevation. Can anyone tell me what is the other spot elevation? It is 2, right? Because 2 is the nearest whole number that is larger than 1.5. Then we subtract these two spot elevations, so we got V is 2 minus 1.5 equals 0.5. And then we need to transform our formula again to solve for H. So we multiply H on both sides of the equation and divide it by S on both sides. So we will get H equals to V over S. And now we plug in the values. 0.05 divided by 5% equals to 10 feet. So we now know we would put our next contour 10 feet to the right. So far, you've known all of the formats starting from rise over run, and I don't recommend you to memorize these formulas because everything will start from rise over run, and as you practice more, you will develop this skill without, putting down things on your drafting paper. You will instantly know how to calculate for different measurements. We're done with the calculations, but here I want to highlight that slopes are proportional. You can understand it in two ways. First, rise and run are proportional. It means that the ratio of rise versus run stays the same for the same slope. In the example below, suppose we have a 4% slope. It means that for every 100 feet of run, the rise changes for 4 feet. In other words, numerically, the rise is always 4% of the run. So now, if you are given a different number of run, 50 feet, for the same slope, you would instantly know that your rise would be 4% of 50, which is 2 feet. Another way to understand slope being proportional is that the slope triangles are proportional, obviously for the same slope. So slope calculations can be visualized as you're resizing the slope triangle proportionally. In the same example here, for a 4% slope, suppose the standard triangle is 4 in 100. So in the case, if the rise shrank from 4 to 1, So cut in quarter, the run would shrink at the same rate. So we would instantly know the run would be a quarter of 100 feet, which is 25 feet. As you can see, this idea that slopes are proportional can really help you better understand slope calculations and slope distance relationships. It can also help you in reading maps, estimating for values. Let's look at some examples. In this slide, I want to show you how the idea that slopes are proportional can also help you estimate slope percentage. In this example, suppose you've determined the slope highlighted in yellow and found out it is 1%. And now I want you to estimate the slope in percentage for the green area. Without using the formula, just eyeball it and use the proportional concept. Okay, here is what I would do. I will compare the contour spacing of these two areas. As you could see, the spacing for the green is about twice the size of the yellow area. So now can anyone take a guess how much the slope would be? It is 0.5%, because in this case, rise stays the same 1 foot, while run doubles in size. Also, slope being proportional can help us estimate for spot elevations. In this example, you're provided two contours and a spot in between them. Let's take an educated guess of how high the spot elevation is in light that slopes are proportional. Alright, I divided the contour spacing into 4 segments. In the reference of these 4 segments, since the spot locates between 0.5 and 0.75, we will be confident to say that the spot is higher than 101.5 and lower than 101.75. If you want to be more accurate, make more divisions. With the help of proportion, we would come to a close enough guess without precise measurements. Following on that, it's very important to develop the skill to identify and memorize common slope percentages and the slope triangles in your head. Suppose you have a plan with contour interval of 1 foot. You should be very familiar with the common slopes and their contour spacings. For instance, 1% slope corresponds to 100 feet contour spacing, 2% to 50 feet, etc. This skill will also help you estimate slopes. For example, suppose the contour spacing is smaller than 100 feet but bigger than 50 feet. We would instantly know it's a slope between 1 and 2%. It can also speed up your design. When you propose a 8% slope, you will keep your contours 12.5 feet apart without a blink. Last but not least, this slide shows you the common slope triangles represented in gradient. As you become more familiar with the slopes, you will be more confident in representing slopes in different formats. A 1% slope is a 1 in 100 slope, 2% a 1 in 50 slope, 4% a 1 in 25 slope, 8% is a 2 in 25 slope. That's everything for today, and thank you. See you in class.